Okay, ma'am. Page number 32. I'm starting from the poem. For all your days, prepare and meet them ever alike. When you are in the anvil, bear. When you are the hammer, strike. Rato motors were mounted on aircraft to provide the additional thrust required during the takeoff, run under certain adverse operating conditions like partially bombed out runways, high altitude airfields, more than the prescribed load, or very high ambient temperatures. The Air Force was in dire need of a large number of Radu motors for their S 22 and HF 24 aircraft. The Russian Rato motor, shown to us at the Tilpat range, was capable of generating a 3000 kg thrust with a total impulse of 24,500 kg seconds. It weighed 220 kg and had a double base propellant encased in steel. The development work was to be carried out at the Space Science and Technology Center with the assistance of Defense Research and Development Organization DRDO, HAL, DTD and PR and Air Headquarters. After a detailed analysis of the available options, I chose a fiberglass motor casing. We decided in favor of a composite propellant which gives a higher specific impulse and aimed at longer burning time to utilize it completely. I also decided to take additional safety measures by incorporating a diaphragm which would rupture if the chamber pressure for some reason exceeded twice the operating pressure. Two significant developments occurred during the work on Rato. The first was the release of a 10-year profile for space research in the country prepared by Professor Sarabhai. This profile was not merely an activity plan laid down by the top man for his team to comply with, it was a theme paper meant for open discussions to be later transformed into a program. In fact, I found it was the romantic manifesto of a person deeply in love with the space research program in his country. The plan mainly centered around the early ideas which had been born at INCOSPAR. It included utilization of satellites for television and developmental education, meteorological observation, and remote sensing for management of natural resources. To this had been added the development and launch of satellite launch vehicles. The active international cooperation dominant in the early years was virtually erased out in this plan, and the emphasis was on self reliance and indigenous technologies. The plan talked about the realization of a SLV for injecting lightweight satellites into low Earth orbit. Upgrading of Indian satellites from laboratory models to space entities and development of a wide range of spacecraft subsystems like the apogee and booster motors, momentum wheel, and solar panel deployment mechanism. It also promised a wide range of technological spins or spin-offs like the gyros, various types of transducers, telemetry, adhesives, and polymer for non-space application. Over and above, there was the dream of an adequate infrastructure that would be capable of supporting R&D in a variety of engineering and scientific disciplines. The second development was the formation of a missile panel in the Ministry of Defense. Both Narayanan and I were inducted as members. The idea of making missiles in our country was exciting, and we spent hours on end studying the missiles of various advanced countries. The distinction between a tactical missile and a strategic missile is often a fine one. Generally, by strategic, it is understood that the missile will fly thousands of kilometers. However, in warfare, this term is used to denote the kind of target rather than its distance from the missile launch. Strategic missiles are those that strike at enemy's heartland, either in counterforce attacks on the strategic forces or in counter value attacks on the society, which in essence means his cities. Tactical weapons are those that influence a battle, and the battle may be by land, sea, or air, or on all three together. The categorization now appears nonsensical as the US Air Force ground launched Tomahawk is used in a tactical role, notwithstanding its range of some 3,000 km. In those days, however, strategic missiles were synonymous with intermediate range ballistic missiles with ranges in the order of 1500 nautical miles or 2780 kilometer intercontinental ballistic missiles with a capability of going even further. GP Captain Narayanan had an ineffable enthusiasm for indigenous guided missiles. He was a great admirer of the strong arm approach of the Russian missile development program. When it could be done there, why not here, where space research has already prepared the soil for a bonanza of missile technology? Narayanan used to needle me. The bitter lessons of two wars in 1962 and 1965 had left the Indian leadership with little choice in the matter of achieving self-reliance in military hardware and weapon systems. A large number of surface to air missiles were obtained from the USSR to guard strategic locations. GP Captain Narayanan passionately advocated the development of these missiles in the country. While working together on Rato Motors and on the missile panel, Narayanan and I played the roles of a student and teacher interchangeably when required. He was very eager to learn about rocketry, and I was very curious to know about airborne weapon system. The depth of Narayanan's conviction and his force of application were inspiring. Right from the day of our pre-dawn visit to the Tilpat range with Professor Sarabhai, Narayanan was always busy with his Rato motor. He had arranged everything that was required before being asked. He obtained funding of rupees 75 lakhs with a further commitment towards any unforeseen cost. You name the thing and I will get it for you. But do not ask for time, he said. At times, I often laughed at his impatience and read for him these lines from T.S. Eliot Hallowman. Between the conception and the creation, between the emotion and the response, falls the shadow. Defense R&D at that time was heavily dependent on imported equipment. Virtually nothing indigenous was available. Together, we made a long shopping list and drew up an import plan. But this made me unhappy. Was there no remedy or alternative? Was this nation doomed to live with screwdriver technology? Could a poor country like India afford this kind of development? One day, while working late in the office, which was quite routine after I took up Rato projects, I saw a young colleague, Jayachandra Babu, going home. Babu had joined us few months ago, and the only thing I knew about him was that he had very positive attitude and was articulate. I called him into my office and did a bit of loud thinking. Do you have any suggestions? I then asked him. Babu remained silent for a while and then asked for time until the next evening to do some homework before answering my question. The next evening, Babu came to me before the appointed time. His face was beaming with promise. We can do it, sir. The Rato system can be made without imports. The only hurdle is the inherent inelasticity in the approach of the organization towards procurement and subcontracting, which would be two major thrust areas to avoid imports. He gave me 7 points, or rather, asked me for seven liberties. Financial approval by a single person instead of an entire hierarchy, air travel for all people on work irrespective of their entitlement, accountability to only one person, lifting of goods by air cargo, subcontracting to the private sector, placement of orders on the basics of technical competence, and expeditious accounting procedures. These demands were unheard of in government establishments, which tend to be conservative, yet I could see the soundness of his proposition. The Rato project was a new game, and there was nothing wrong if it was to be played with a new set of rules. I weighed all the pros and cons of Babu's suggestion for a whole night and finally decided to present them to Professor Sarabhai. Hearing my plea for administrative liberalization and seeing the merits behind it, Professor Sarabhai approved the proposals without a second thought. Through his suggestions, Babu had highlighted the importance of business acumen in developmental work with high stakes. To make things move faster within existing work parameters, you have to pump in more people, more material, and more money. If you can't do that, change your parameters. Instinctive businessman that he was, Babu did not remain long with us and left ISRO for greener pastures in Nigeria. I could never forget Babu's common sense in financial matter. We had opted for a composite structure for the Rato motor, causing a filament fiberglass slash epoxy. We had also gone in for a high energy composite propellant and an event based ignition and jettisoning system in the real time. A canted nozzle was designed to deflect the jet away from the aircraft. We conducted the first static test of RATO in the 12th month of the project initiation. Within the next 4 months, we conducted 64 static tests, and we were just about 20 engineers working on the project. 6. Movers. The Future Satellite Launch Vehicle (SLV) also been conceived by this time, recognizing the immense socio-economic benefits of space technology. Professor Sarabhai decided in 1969 to go full steam ahead with the task of establishing indigenous capability in building and launching our own satellites. He personally participated in an aerial survey of the east coast for a possible site for launching satellite launch vehicles and large rockets. Professor Sarabhai was concentrating on the east coast in order to let the launch vehicle take full advantage of the Earth's west to east rotation. He finally selected the Sriharikota Island, 100 kilometers north of Madras, now Chennai, and thus the SHAR rocket launch station was born. The crescent shaped island has a maximum width of 8 kilometers and lies alongside the coastline. The island is as big as Madras city, the Buckingham Canal, and the Pulicat Lake from its western boundary. In 1968, we had formed the Indian Rocket Society. Soon after, the INCOSPAR was reconstituted and as an advisory body under the Indian National Science Academy, and the Indian Space Research Organization was created under the Department of Atomic Energy to conduct space research in the country. By this time, Professor Sarabhai had already handpicked and team to give form to his dream of an Indian SLV. I consider myself fortunate to have been chosen to be a project leader. Professor Sarabhai gave me the additional responsibility of designing the fourth stage of SLV. Dr. V.R. Govarikar, M.R. Kurup, and A.E. Muthanayagam were given the task of designing the other three stages. What made Professor Sarabhai pick a few of us for this great mission? One reason seems to be our professional background. Dr. Govarikar was doing outstanding work in the field of composite propellants. M.R. Kurup had established an excellent laboratory for propellants propulsion and pyrotechnics. Muthanayagam had proved himself in the field of high energy propellants. The fourth stage was to be a composite structure and called for a large number of innovation in fabrication technology. Perhaps that was why I was brought in. I laid the foundation for stage 4 on two rocks sensible approximation and unawed support. I have always considered the price of perfection prohibitive and allowed mistakes as a part of learning process. I prefer a dash of daring and persistence to perfection. I have always supported learning on part of my team members by paying vigilant attention to each of their attempts, be they successful or unsuccessful. In my group, progress was recognized and reinforced at every tiny step. Although I provided access to all information that my co workers in stage 4 needed. I found I could not spend enough time to be a useful facilitator and a source of support. I wondered if there was something wrong with the way in which I managed my time. At this stage, Professor Sarabhai brought a French visitor to our work center to point out the problem to me. The gentleman was Professor Kurian, president of CNES, Central Nationale de Etudes and Specialities, our counterpart in France. They were then developing the Diamond launch vehicles. Professor Curian was thorough professional. Together, Professor Sarabhai and Professor Kurian helped me set a target. While they discussed the means by which I could reach it, they also cautioned me about the possibilities of failure. When I arrived to a better awareness of stage 4 problems through the supportive counseling of Professor Curry and Professor Sarabhai's catalytic intervention led Professor Kurian to reinterpret his own progress in the Diamond program. Professor Kurian advised Professor Sarabhai to relieve me of all minor jobs which posed little challenge to give me more opportunities for achievement. He was so impressed by our well planned efforts that he inquired if we could make the diamond's fourth stage. I recall how this brought a subtle smile to Professor Sarabhai's face. As a matter of fact, the Diamond and SLV airframes were incompatible. The diameters were quite different, and to attain interchangeability, some radical innovations were required. I wondered where I should start. I decided to look around for solutions among my own colleagues. I used to carefully observe my colleagues to see if their daily routine reflected their desire to constantly experiment. I also started asking and listening to anyone who showed the slightest promise. Some of my friends cautioned me about what they termed as my naivete. I made it an unfailing routine to make notes on individual suggestions and gave handwritten notes to colleagues in engineering and design, requesting concrete follow up action within 5 or 10 days. This method worked wonderfully well. Professor Kurian testified while reviewing our progress that we had achieved in a year's time what our counterparts in Europe could barely manage in 3 years. Our plus point, he noted, was that each of us worked with those below and above in the hierarchy. I made it a point to have the team meet at least once every week. Though it took up time and energy, I considered it essential. How good is the leader? No better than his people and their commitment and participation in the project as full partners. The fact that I got them all together to share whatever little development had been achieved, results, experiences, small successes, and the like seemed to me worth putting all my energy and time into. It was very small price to pay for that commitment and sense of teamwork which could in fact be called trust. With my own small group of people, I found leaders and learned the leaders existed at every level. This was another important aspect of management that I learned. We had modified the existing SLV-4 stage design to suit the Diamond airframe. It was reconfigured and upgraded from a 250 kg 400 millimeter diameter stage to a 600 kg 650 millimeter diameter stage. After 2 years' effort, when we were about to deliver it to CNES, the French suddenly cancelled their Diamond BC program. They told us they did not need our stage 4 anymore. It was a great shock, making me relive the earlier disappointment at Dehradun when I failed to get into the Air Force and at Bangalore when the Nandi project was aborted at ADE. I invested great hope and effort in the fourth stage so that it could be flown with the Diamond rocket. The other three stages of SLV involving enormous work in the area of rocket propulsion were at least 5 years away. However, it did not take me long to shelve the disappointment of Diamond BC Stage 4. After all, I had thoroughly enjoyed the work working on this project. In time, Rato filled the vacuum created in me by the Diamond BC stage. When the Rato project was underway, the SLV project slowly started taking shape. Competence for all major systems of a launch vehicle had been established in Tumba by now. Through their outstanding efforts, Vasant Guwarikar, MP Kurup, and Muthanayagam prepared TERLS for a big leap in rocketry. Professor Sarabhai was an exemplar in the art of team building. On one occasion, he had to identify a person who could be given the responsibility for developing a telecommand system for the SLV. Two men were competent to carry out this task. One was the seasoned and sophisticated U.R. Rao, and the other was relatively unknown experimenter, G. Madhavan Nair. Although I was deeply impressed by Madhavan Nair's dedication and abilities, I did not rate his chances as very good. During one of Professor Sarabhai's routine visits, Madhavan Nair boldly demonstrated his improvised but highly reliable telecommand system. Professor Sarabhai did not take much time to back the young experimenter in preference to an established expert. Madhavan Nair not only lived up to the expectations of his leader but even went beyond them. He was to later become the project director of the Polar Satellite Launch Vehicle (PSLV). SLVs and missiles can be called first cousins. They are different in concept and purpose but come from same bloodline of rocketry. A massive missile development project has been taken by DRDO at the Defense Research and Development Laboratory, Hyderabad. As the pace of this surface to air missile development project increased, the frequency of the panel meetings and my interaction with GP Captain Narayanan also increased. In 1968, Professor Sarabhai came to Tumba on one of his routine visits. He was shown the operation of the nose cone jettisoning mechanism. As always, we were all anxious to share the results of our work with Professor Sarabhai. We requested Professor Sarabhai to formally activate the pyro system through a timer circuit. Professor Sarabhai smiled and pressed the button. To our horror, nothing happened. We were dumbstruck. I looked at Pramod Kale, who had designed and integrated the timer circuit. In a flash, each of us mentally went through an analysis of the failure. We requested Professor Sarabhai to wait for a few minutes. Then we detached the timer device, giving direct connection to the pyros. Professor Sarabhai pressed the button again. The pyros were fired and the nose cone was jettisoned. Professor Sarabhai congratulated Kale and me, but his expression suggested that his thoughts were elsewhere. We could not guess what was on his mind. The suspense did not last for long, and I got a call from Professor Sarabhai's secretary to meet him after dinner for an important discussion. Professor Sarabhai was staying at Kovalam Palace Hotel, his usual home where he was in Trivandrum. I was slightly perplexed by the summons. Professor Sarabhai greeted me with his customary warmth. He talked of the rocket launching station, envisaging facilities like launch pads, blockhouses, radar, telemetry, and so on. Things which are taken for granted in Indian space research today. Then he brought up the incident that had occurred that morning. That was exactly what I had feared. My apprehension of a reproach from my leader, however, was unfounded. Professor Sarabhai did not conclude that the failure of pyro timer circuit was the outcome of insufficient knowledge and lack of skill on the part of his people or of faulty understanding at the direction stage. He asked me instead if we were unenthused by a job did not pose sufficient challenge. He also asked me to consider if my work was possibly being affected by any problem of which I was hitherto unaware. He finally put his finger on the key issue. We lacked a single roof to carry out system integration of all our rocket stages and rocket systems. Electrical and mechanical integration work was going on with a significant phase difference both in time and in space. There was little effort to bring together the desperate work on electrical and mechanical integration. Professor Sarabhai spent the next hour in redefining our tasks, and in the small hours of the morning, the decision to set up a rocket engineering section was taken. Mistakes can delay or prevent the proper achievement of the objectives of individuals and organizations, but a visionary like Professor Sarabhai can use errors as opportunities to promote innovation and the development of new ideas. He was not especially concerned with the mistake in the timer circuit, least of all with pinning blame for it. Professor Sarabhai's approach to mistakes rested on assumption that were inevitably but generally manageable. It was in the handling of the crisis that arose a consequence that talent could often be revealed. I later realized by experience that the best way to prevent errors was to anticipate them. But this time, by a strange twist of fate, The failure of the timer circuit led to the birth of a rocket engineering laboratory. It was my usual practice to brief Professor Sarabhai after every missile panel meeting. After attending one such meeting in Delhi on 30th December 1971, I was returning to Trivandrum. Professor Sarabhai was visiting Tumba at very day to review the SLV design. I spoke to him on the telephone from the airport lounge about the salient points that had emerged at the panel meeting. He instructed me to wait at Trivandrum airport after disembarking from the Delhi flight and to meet him there before his departure for Bombay the same night. When I reached Trivandrum, a pall of gloom hung in the air. The aircraft ladder operator, Kuti, told me in a choked voice that Professor Sarabhai was no more. He had passed away few hours ago, following a cardiac arrest. I was shocked to the core. It had happened within an hour of our conversation. It was a great blow to me and a huge loss to Indian science. That night passed in preparation for airlifting Professor Sarabhai's body for the cremation in Ahmedabad. For 5 years, between 1966 to 1971, about 22 scientists and engineers had worked closely with Professor Sarabhai. All of them were later to take charge of important scientific project. Not only was Professor Sarabhai a great scientist, but also a great leader. I still remember him reviewing the bi-monthly progress of the design projects of SLV in June 1970. Presentation on stages 1 to 4 were arranged. The first three presentations went through smoothly. Mine was the last presentation. I introduced five of my team members who had contributed in various ways to design. To everybody's surprise, each of them presented his portion of work with authority and confidence. The presentations were discussed at length, and the conclusion was that satisfactory progress has been made. Suddenly, a senior scientist who worked closely with Professor Sarabhai turned to me and inquired, well, the presentations for your project were made by your team members based on their work, but what did you do for the project? That was the first time I saw Professor Sarabhai really annoyed. He told his colleague, you ought to know what project management is all about. We just witnessed an excellent example. It was an outstanding demonstration of teamwork. I have always seen a project leader as an integrator of people, and that is precisely what Kalam is. I consider Professor Sarabhai as the Mahatma Gandhi of Indian space, generating leadership qualities in his team and inspiring them through both ideas and example. After an interim arrangement with Professor M.G.K. Menon at the helm, Professor Satish Dhawan was given the responsibility of heading ISRO. The whole complex at Tumba, which included TERLS, the Space Science and Technology Center SSTC, the RPP, the Rocket Fabrication Facility, and the Propellant Fuel Complex, were merged together to form an integrated space center and christened the Vikram Sarabhai Space Center as a tribute to the man to whom owed its existence. The renowned metallurgist Dr. Bram Prakash took over as the first director of VSSC. The RATO system was successfully tested on 8 October 1972 at Bareilly Air Force Station in Uttar Pradesh, when a high performance Sukhoi 16 jet aircraft became airborne after a short run of 1200 meters as against its usual run of 2 kilometers. We used the 66th Rato motor in the test. The demonstration was watched by Air Marshal Shivdev Singh and Dr. B.D. Nag Chaudhary, then the scientific advisor to the defense minister. This effort was said to have saved approximately rupees 4 crores in foreign exchange. The vision of the industrialist scientist had finally borne fruit. Before taking up the responsibility of organizing space research in India and becoming the chairman of INCOSPAR, Professor Sarabhai had established a number of successful industrial enterprises. He was aware that scientific research could not survive in isolation, away from industry. Professor Sarabhai founded Sarabhai Chemicals, Sarabhai Glass, Sarabhai Gegi Limited, Sarabhai Merck Limited, and the Sarabhai Engineering Group. His Swastik oil mills did pioneering work in the extraction of oil from oil seeds, manufacture of synthetic detergents, and of cosmetics. He geared Standard Pharmaceutical Limited to enable large scale manufacturing of penicillin, which was imported from abroad at astronomical cost at that time. Now, with indigenization of Rato, his mission had acquired new dimension, independence in the manufacture of military hardware and potential saving of crores of rupees in foreign exchange. I recall this on the day of successful trial of Rato system. Including trial expenses, we spent less than rupees 25 lakhs on the entire project. The Indian Rato could be produced at rupees 17,000 apiece and it replaced the imported Rato which cost rupees 33,000. At Vikram Sarabhai Space Center, work on SLV went on at full swing. All subsystems has been designed, technologies identified, processes established, work centers selected, manpower and earmarked and schedules drawn. The only hitch was lack of management structure to effectively handle this mega project and coordinate activities which were spread over large number of work centers with their own ways of working and management. Professor Dhawan, in consultation with Dr. Brahm Prakash, picked me for this job. I was appointed the project manager, SLV, and reported directly to the director, VSSC. My first task was to work out a project management plan. I wondered why I was selected for this task when there were stalwarts like Govarikar, Muthanayagam, and Kurup around. With organizers like Iswadas, Arva Mudan, and S.C. Gupta available, how would I do better? I articulated my doubts to Dr. Brahm Prakash. He told me not to focus on what I saw as other people's strength compared to my own, but instead to attempt to expand their abilities. Dr. Brahm Prakash advised me to take care of performance degraders and cautioned me against outrightly seeking optimal performance for the participating work centers from the participating work centers.
Priya,
Every,
you can
yeah.
find a place where you can stop.
Okay, ma'am.
Yeah.
So maybe only this paragraph or the
Yeah,
like
yeah.
I,
Finish the paragraph and you can stop. That's what I
okay.
meant.
Okay, ma'am. So Dr. Brahm Prakash advised me to take care of the performance degraders and cautioned me against outrightly seeking optimal performance from the participating work centers. Everyone will work to create their bit of SLV. Your problem is going to be your dependency on others in accomplishing the total SLV. The SLV mission will be accomplished with and through a large number of people. You will require a tremendous amount of tolerance and patience, he said. It reminded me of what my father used to read to me from the Holy Quran on the distinction between right and wrong. We have sent not to apostle before you who did not eat or walk about the market squares. We test you by means of one another. Will you not have patience? Yeah, ma'am. I'll stop here.
So Taranjit, you can go with what you liked about this play, and then Priya about you, and then we can close it.
Okay.
The best thing that I liked about was I forgot the name of that person who moved to Nigeria for greener pastures. What was his name? So that was something that like even
Yeah, Babu.
yeah,
Babu.
Babu. So he was like Dr. Kalam has mentioned so very minute. I've been saying time and again, very minute things in a very subtle way. Like it is not that he could have used harsh words also, but then and the very best thing is that he has given importance to each and every person whom he has worked with, even though very small or big, whoever he has worked with. And he has always questioned his own capabilities, whether I'm capable for this work. The last what we are reading, so he went to Dr. Brahma and asked him whether I'm capable of this, shall I be doing this? So they questioning your own abilities to make sure that yes, you can achieve this. This is a very great quality, and definitely he was a great personality. There's no doubt about it. This is what I feel is important in this part what we read today.
Yeah, and also I liked when his team was presenting the project. So everyone he gave a chance to every one of his team to explain their work. But when somebody asked, they all said what they did. But what is your work to Kalamji? Then Sarabhai said that is his work of management.
Yes.
So that was the beautiful part.
There's a quote about Einstein, what Einstein had said, that if it is not simple, then it cannot be explained. Any
Mm.
definition should be very be simple, and it should then only it can be explained. If it is not simple, it is not explained.
Yeah.
And giving credit to the people, those who work for you, is a quality very few people or very great people only possess this quality.
Yeah, exactly.
So shall we take we are done for the day. Thank you so much, Priya. Thank you so much for stepping in, and thank you, Taranjit, for being so regular.
Thank you so much, Priya. You read very nicely. I
Um,
thought that if other children were there, like I knew, but there were few phrases which I wanted you to ask them, but unfortunately today no one was there. So you read very well. Thank you so much.
Thank you, ma'am. Thank you
Thank
so
you,
much.
Priya. Good
Thank you,
night.
ma'am. Good night.